Hi guys, today we're going to be talking about electronegativity. So the first thing that we're going to be looking at is the definition of electronegativity. Electronegativity is the relative ability of an atom to pull electrons towards itself. And electronegativity is affected by two main things: nuclear charge and atomic radius. So the higher your nuclear charge and the smaller your atomic radius, the more electronegative your element is going to be. So now let's look at the periodic table. In this case, as you go down the group, the size of your atom increases. So because of that, the pull of the nucleus on the atoms decreases and the nuclear charge also decreases. Furthermore, as you go down the group, the number of shells is going to continue to increase because the number of electrons is increasing. And because of that, your radius is going to become larger. So as you go down the group, your radius becomes larger and your nuclear charge decreases. So because of that, the electronegativity will also decrease. On the other hand, as you go across the period, the nuclear charge is going to increase. So because of that, the electronegativity is also going to increase. In this case, electronegativity will increase in this direction, diagonally. So as you go from cesium to fluorine, the electronegativity will increase. So this is the trend in electronegativity. We will not consider francium in this case because it's radioactive. So over here, let's compare lithium and fluorine, which are both in period 2. So in this case, lithium has 3 protons and fluorine has 9 protons. So you can see that the overall nuclear charge on fluorine is going to be more. So if the charge on your nucleus is more, it's going to be able to pull more electrons towards itself because positive charge attracts negative charge. Now we're going to be talking about bond polarity, which occurs because of a drift of electrons. In this case, if we look at HF, hydrogen is less electronegative than fluorine. So in this case, electrons are going to be attracted towards fluorine. Because of that, fluorine will have a partial negative charge because of the separation of charge that takes place. Because electrons are being pulled away from hydrogen, it's going to have a partial positive charge. So a molecule in which one element is more electronegative than the other is termed as a polar molecule. Now we're going to move on to the Pauling scale, which is a scale used to measure how electronegative an atom is. So in this case, the most electronegative elements are usually nonmetals and the least electronegative elements are usually metals. So in this case, the higher the value on the Pauling scale, the more electronegative your element is going to be. So in this case, the scale ranges from 0 to 4. And there are 4 values that we need to learn. So for fluorine, it's going to be the highest, which is 4. For oxygen, it's going to be 3.5. For chlorine, it's 3. And for nitrogen, it's also 3. The last thing that we're going to be looking at is examples of polar and nonpolar compounds. So towards the left, I've made polar compounds in pink. So in this case, if you look at HCl first, chlorine is going to be more electronegative. So it's going to pull the electron density towards itself compared to hydrogen. So in this case, since chlorine is pulling the electron density towards itself, it's going to be partial negative and hydrogen will be partial positive. Over here, chlorine is more electronegative than carbon. So in this case, chlorine is going to pull the electron density towards itself. And because of that, it's going to be partial negative. And all the other atoms are going to be partial positive because chlorine is also more electronegative than hydrogen. In this case, oxygen is going to be more electronegative than hydrogen. So it's going to pull the electron density towards itself from both the directions. And because of that, it's going to have a high region of electron density around it. So it's going to be partial negative. And the hydrogens will be partial positive. In this case, nitrogen is more electronegative than hydrogen. So it's going to pull the electron density towards itself. And it's going to be partial negative, and the other atoms are going to be partial positive. Over here, out of all the elements in this molecule, chlorine is going to be the most electronegative. So it's going to pull all the electron density towards itself. And it's going to become partial negative, and all the other atoms are going to be partial positive. And the last polar molecule that we're going to be looking at is going to be HCl. So in this case, chlorine is going to pull electron density towards himself, and it's going to be partial negative, and this is going to be partial positive. So if you're having trouble figuring out which element is more electronegative, you should look at the periodic table and you should see the trends in the periodic table, so it's going to be easier for you to figure out which element is more electronegative. The next thing that we're going to be doing is we're going to be looking at nonpolar compounds. So in this case, even though chlorine is going to be more electronegative, it's going to pull electron density towards itself from the top and the bottom, towards the right and towards the left. So the effect of this electronegativity will be cancelled out. So in this case, if your dipoles are moving in the opposite direction, they're going to be cancelling out. And if they're moving in the same direction, they're going to be reinforced. As you can see over here, they were moving in the same direction. So they were reinforced. In this case of methane CH4, the electronegativity difference between carbon and hydrogen is going to be 2 less. So in this case, this is also going to be nonpolar. Over here, even though oxygen is more electronegative, it's going to pull electron density from this side and from this side. And because of that, the net effect is going to cancel out. So this is also going to be nonpolar. In this case, in ethene, similar to ethane, the electronegativity difference between carbon and hydrogen is 2 less. And over here, since these arrows are moving in opposite directions, the electronegativity difference is going to cancel out, and this is also going to be nonpolar. So all the molecules on this side are nonpolar, and on this side, they're polar.